Okay, guys, for information, I am recording this class. Okay, guys. So this semester, first of all, may I audible to everyone? Okay, Kevin, reply to me. Am I audible to you? Kevin Kumar, are you there? Okay. Okay, thank you. Okay, this semester, I am going to handle structural design and drawing subject for you. Okay, so this subject is a uh, problematic subject. Okay, so this subject is of a consists of both problematic and practical is also in this subject. Okay, so this is the syllabus of your subject. Okay, structural design and drawing. Okay, so in this subject you are going to study about the design principles of retaining structures, bridge components, and industrial structures. Okay, so you have to gather the knowledge of retaining structures, bridge components, and industrial structures. After that, you can able to design those structures also. Okay, so unit one covers the retaining walls, and unit two is about flat slab and bridges. So unit three, liquid storage structures. Liquid storage structures, nothing but water tanks only, rectangular water tank, maybe an underground or overhead water tanks. Okay, so unit four, industrial structures. So in unit four, you are going to study about roof truss only. Okay, so unit five is about girders and connections. So apart from these five units, you are also having a practical experiments also. Okay, so practical experiments you have to design and you have to draw the experiments, design structures. Okay, so in practical also it is of two parts, part A and part B. So part A is about RCC structures. Okay, so in part A you are having seven experiments. Okay, design of rectangular column and footing. After design, you have to draw the reinforcements diagram. Okay, so first one rectangular column and footing, and second one is combined footing with two columns. Third one RCC one way two way slab beam system. So similarly, there are many experiments. Okay, in part B, it is about steel structures. Okay, so first experiment built up column base and foundation. So you have to design built up column base and foundation. After that, you have to draw the reinforcement diagram also. Okay. So normally we used to draw the reinforcement diagrams in CAD software only. Okay. So totally 14 experiments. So this subject is of 75 periods. Okay. So we have a design also. Okay. This is all these five units are theory portion. Okay. In the five units, you learn about the design of retaining wall, flat slab. Okay. After you learning design procedures, and in practical, we have to draw the reinforcement diagram. Okay. In exam, so exam also part you are having two parts. Okay, so theory part consists of 80 percentage mark and practical is of 20 percentage mark. Okay, the question paper pattern also they gave in the syllabus itself. So 520 marks each from each unit. Okay, so 12 marks for design purpose and 8 marks for free and drawing in the exam, theory exam. But in a practical, you have to design and draw the by using software. Okay, so practical exam also you will will conduct the exam for 100 marks only. After only we convert into 20 percentage. Okay, so in practical exam, two questions will come from two parts, part A and part B. So both RCC structure design and steel structure design, you have to design and draw. Okay, so this is your syllabus. So unit one is retaining walls. So in unit one, retaining walls. So we are going to study about reinforced concrete cantilever and counterfort retaining walls. Okay, so two design will come. ordinary cantilever retaining wall and counterfort retaining wall. We have to design and draw the reinforcement diagram, and we have to horizontal backfill with the surcharge, and we have to design shear key also in the those cantilever retaining wall. We have to design with shear key. Shear key is a component in retaining wall. Okay, so this point will come in this unit one. Okay, so in coming slides I'm going to teach about the introduction about retaining walls, types of retaining walls, definitions of retaining walls, and all we'll see. So introduction. So retaining walls. In the name itself, we can know the meaning of the retaining walls. So retaining wall is nothing but wall. It retains something. Okay. So that only using this name, retaining walls. So retaining walls are used to retain earth. Okay. So it retains the earth in a vertical position at locations where an abrupt change in level occurs. So retaining walls is nothing but wall. It's used to retain earth. Earth is nothing but soil mass only. Okay. So retaining walls always will be in a vertical position at location. Where will be retaining walls will be used means in vertical position where the land may change abruptly. Okay. The walls therefore prevents the retained earth from assuming its natural angle of repose. Okay. So we are providing walls to uh, retain the earth. Okay. So that only. So this is an image of a earth stone retaining wall. Okay, so this is the stone retaining wall. It retains the earth on one side. Okay, we normally name it as a back side of the retaining wall, and this is the front side of the retaining wall. This is also a retaining wall, stone retaining wall. It retains the artificially landfill. Okay, so previous one is a naturally landfill. Okay, but in this like it is a man-made landfill. So for this we are using retaining wall for retain this landfill. So this is one more image for a stone retaining wall. This one is the brick retaining wall. So this is one more image of retaining walls. Okay, it retains the earth fill. Okay, this is one more image of retaining wall with different aesthetical purpose, architectural purpose also we can use. It is one more image of retaining wall. And this one is the concrete retaining wall. Okay. So retaining walls also can be used in construction sites also. Okay. So previous it is in a location naturally available location where retaining walls are they used. But in this it is used in construction site. Okay. So this is retaining wall failure at the Shinkang Dam. Okay, so retaining wall used in the dams and all. Okay, so failure image only this failure in retaining wall. This is one more image failure of retaining wall due to water pressure. Because of more water pressure, retaining wall will also fail. And this is another image of retaining wall failure in Austria on 30th October 2012. So next is the applications of the retaining wall. So a retaining wall maintaining the difference between the elevations of the ground surface. Okay, suppose we want to maintain the elevations of the ground surface means we can use retaining wall. This is a retaining wall used for maintaining the difference between the elevations of the ground surface. So this is one of the application. And we can use retaining wall as a basement. Okay, in many apartments or malls and all, they are having underground parkings, more than two underground parking. So they use retaining wall as a basement wall. And this is one more example of the retaining wall in tunnel portal. Okay, so this is the retaining wall. This is another application. So maintaining the level between a highway and a contour land. Okay, so this is the retaining wall in contour lander. Okay, so definitions of a retaining wall. So retaining wall is a structure. Okay, so structure only used for maintaining the ground surfaces at different elevations on either side of the it. Okay, so we ask if they what is a retaining wall? Defined retaining wall means a retaining wall is nothing but it is a structure only used for maintaining the ground surfaces at different elevations on either side of it. So some of the important points of the in the design of retaining wall. So all permanent walls and components shall be designed for a minimum service life of 75 years. If you want to, if you are guys are going to design retaining wall means the minimum service life of a retaining wall should be of 75 years. The next point, corrosion protection is required for all permanent and temporary walls in aggressive environments. So in aggressive environments, some retaining walls may be in a normal environment, some may be in aggressive environments, maybe in seashore areas and all. So if we are using a if we are building a retaining wall in those aggressive environments, means it should be against a corrosion protection also. And retaining walls are usually built to hold back soil mass. Okay, they are also provided to maintain the grounds at two different levels. Okay, these are some important points about retaining walls. Next, the parts of the retaining wall. Okay, so this is the retaining wall. Okay, so the backside portion of the retaining wall is this. Okay, so here only the soil mass or lands are retained by the structure. Okay, so the soil mass is termed as backfill. Okay, and this is the front side portion of the retaining wall. So this one is the backside portion, and this one is the front side portion of the retaining wall. So the slab in the front side portion of the retaining wall is termed as toe, and the slab in the back side portion of the retaining wall is termed as heel. And the largest structure in the retaining wall is termed as stem, and this portion is termed as shear key. Okay, so retaining walls, some retaining walls are shear key and some it don't. Okay, if we provide shear key in the retaining wall means it has advantages. It resists the retaining wall against overturning. Okay, if we don't provide shear key means overturning may occur easily. Okay, so these are the components in the retaining wall. So this is the backside portion. So the landfill on the backside portion is termed as the backfill, and this is the front side portion of the retaining wall. Okay, the slab on the front side is termed as toe, and the slab on the right side, that is backside, is termed as heel, and shear key. Okay, it is option only shear key, but if we provide shear key means it has advantages. The largest part of the structure in retaining wall is termed as stem. The next slide is about types of retaining wall. Actually, there are 10 types of retaining walls: gravity retaining walls, semi-gravity, cantilever retaining walls, counterfort retaining walls, anchored, buttress retaining walls, sheet piling, segmental, wooden retaining walls, and gabion retaining walls. We'll see one by one. Okay. So first is gravity retaining walls. So gravity wall provides stability by virtue of its own weight and therefore is rather massive in size. Okay, so gravity walls, uh, by the name itself, we know what is gravity wall. Okay, it's by using its own weight only, this is easy to prove. Okay, so it is massive in size only. Second point is usually built in stone masonry and occasionally in plain concrete. Okay, so gravity walls may be in stone masonry and occasionally in plain concrete only. The thickness of the wall is also governed by need to eliminate or limit the resulting tensile stress to its permissible stress. So we know what is gravity wall. So gravity wall is of its own weight only. So it is massive in size, but it has some disadvantages also. We cannot provide more thickness of the wall. Okay? If we provide the more wall thickness, means it will also leads to failure in tensile stress. Okay, so there must be a permissible limit in wall thickness. So plain concrete gravity walls are not used for heights exceeding about 3 meter for obvious economic reason. Okay, so if we are using gravity walls, if we are built gravity walls by using plain concrete, means the height is exceeding height is of about limit 3 meter only. We cannot build more than 3 meter. Okay, so by using plain concrete, the height of the gravity wall or the gravity retaining wall is about 3 meter only. Okay, so this is the image of the gravity retaining wall. Okay, so in gravity retaining wall, we don't have a toe, heel slab, and all. Okay, so normally this is the components of a retaining wall. This is a cantilever retaining wall. Okay, most often we use cantilever retaining wall only. In cantilever retaining wall only, we are having toe portion, heel portion, and all. But in gravity retaining walls, we don't have a toe slab, heel slab, and all. Okay, so gravity retaining wall will be like this only. So self weight acting in the gravity retaining wall, and the force of the landfill or backfill will act like this. Okay, so because of these two forces, the resultant force will act. Okay, this is the angle of repose. So these are the some of the image of a gravity retaining wall. Okay, this gravity retaining wall is built by using masonry unit. Masonry unit means building of bricks, cement mortar. Okay, bricks. If we use bricks, means brick masonry. Stone means stone masonry. Okay, so this is masonry unit. This is stone retaining wall, stone gravity retaining wall. Okay, and this is by means of poured concrete. Next is semi-gravity retaining wall. So first we saw about gravity wall. So second type of retaining wall is about semi-gravity retaining walls. So semi-gravity walls resist external forces by the combined action of self-weight of above the footing and the fluxural resistance of the wall components also. Okay. So by combined action of self-weight of soil and fluxural resistance of the wall components only, it resists the external forces. So concrete cantilever wall is an example and consists of a reinforced concrete stem and a base footing. Okay, so in gravity walls, I mentioned about it. In gravity walls, we don't have toe portion and heel portion and all, but in semi-gravity wall, we may have toe portion and heel portion and all. Okay, so these walls are non-proprietary. Non-proprietary means that it is not an ownership. Okay, so the toe portion and the heel portion and all not belongs to that semi-gravity walls. That only they are mentioning. So semi-gravity wall, the size of section of a gravity retaining wall may be reduced if a small amount of reinforcement is provided near the base. Such walls are known as semi-gravity retaining walls. Okay, so we can reduce the height of the retaining wall by providing a small amount of reinforcements. Okay, so these type of gravity walls also comes under the semi-gravity retaining walls. The next one is the cantilever wall. Okay, so this is the cantilever retaining wall. I already mentioned the portions, components, and all. Okay, parts and components. So the front side slab is termed as toe slab, and the back side slab is termed as heel slab. So here it is the backfill or landfill or earthfill. Okay, so there are different technical terms. Okay, the soil mass only we are naming as earthfill, a backfill, or landfill. Okay, so this one is a stem. So in this retaining wall, there is no shear key.
Sir, voice break agreed, sir. The voice is breaking, sir.
Hmm. Okay. Chandru, Chandru, now it is audible to you. Chandru, Chandru, can you hear me?
Yes.
Mm.
Yes, 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 yes.
Mm. Do you have any doubts? So far, I
The
talked about
voice break.
mm,
Nothing, sir.
nothing. Okay.
Yes, yes.
Others? What about others? Does anybody have any doubts? Okay, I'll continue. So this is one more image for cantilever retaining
Okay.
wall. So this red color line is the earth pressure. Okay, the pressure of the landfill or soil mass. Okay, so blue color line indicates the gravity vector. That is self weight of the wall only. Okay, self weight of the retaining wall. So green color line is the reaction forces. Okay, so because of the landfill on this side, the weight of the landfill also act on this side. Okay, so this is an action force and this is the reaction force. So in this image, this is also one type of retaining wall. Okay, so this is the counterfort. Okay, this is the counterfort retaining wall. This type of retaining wall is named as counterfort retaining wall. Okay, so same toe portion, heel portion, and this is the counterfort. Kadir,
Sir.
Kadir, do you have any doubt?
No, sir.
Okay,
No, sir.
okay. Switch off your audio while I'm taking class. Switch off your audio and video and all. Okay, maybe echoes will occur. So this is another image of cantilever retaining wall. Okay. So this is the back side now. Okay. This is the back side because the landfill is here only. Okay. So this is heel portion. This is toe portion. Okay. And this one is the stem. So driving force because of the land mass, the driving force will act in this direction. Okay. So original ground surface. And this is also a cantilever retaining wall only. Okay, so stem portion and with the reinforcement. Okay, this is a reinforcement only. So and we are having a large flexural stress at base of the stem. Okay, for supportive purpose only. Okay, against overturning. So this one is the heel and this one is the toe portion. So these are the some of the images of cantilever retaining wall. Okay, this is L-shaped cantilever retaining wall. So next is L-shaped cantilever retaining wall. Okay, so in L-shaped cantilever retaining wall, stem acts as a vertical cantilever. Stem is this one. Okay, the stem acts as a vertical cantilever under the lateral earth pressure. Under the lateral earth pressure, eel slab acts as a horizontal cantilever. Okay, so in a L-shaped cantilever, there are two portions: stem and eel portion. Okay, so because the landmass will be here only, so eel portion will be there. No toe portion will not be there. Okay, so eel slab also acts as a horizontal cantilever under the action of the weight of retained earth. Toe slab will not be there. Okay, they mentioned toe slab acts as a cantilever under the action of resulting soil pressure, but toe slab will not be there in L-shaped cantilever retaining wall. Naveen, others don't switch on your audio. Okay, this one is a reversed L-shaped cantilever retaining wall. Okay, so it resists the horizontal earth pressure as well. Okay, maybe so a L-shaped retaining wall and reversed L-shaped retaining wall. Okay, so reversed L-shaped retaining wall resists the horizontal earth pressure as well as other vertical pressure by the way of bending of various components acting as a cantilever, maybe L-shaped or T-shaped. Okay, so one more audio video file. We'll see this video file.
water. The first video in this series showed retaining walls serve the important role of holding back soil and rock, just as dams hold back water. The first video in this series showed that granular materials such as soil and rock generate horizontal pressures that increase linearly with depth. Retaining walls must resist these pressures, and many strategies exist for doing so. In this video, we focus on the popular L-shaped cantilever design. If you are going to use an L-shaped wall to hold back soil and rock, as represented by these marbles, would you point the bottom leg towards the marbles or away from them? Many people would say that the base of the L should face away from the marbles. They probably realize that it is hard to tip the wall over towards the left if the bottom leg points in that direction. In engineering, we call tipping like this overturning. If the bottom leg points the other way around, it is easy to make the wall overturn. So easy, in fact, that I can do it with just a puff of air. It looks like the case is closed. Or is it? Before we declare a final verdict, let's use the model to find out what happens when the bottom leg points to the left, away from the marbles. As we add marbles, we discovered that the horizontal forces they produce create yet another mode of failure, namely sliding of the wall. And this occurs when the marbles reach a depth of 3 centimeters. In the model, we can increase the friction between the retaining wall and the base by placing a rubber mat between them. You will have to do some extra reading if you want to find out how they achieve this end in the real world. As you can see, increasing the friction allows our model wall to support a noticeably greater depth of marbles, but it still eventually fails by overturning, in this case when the depth reaches 8 centimeters. Now let's turn the wall around, so its bottom leg points towards the right, the side where the marbles will be placed. We again use a rubber sheet to prevent sliding, and we add some marbles. As before, the marbles generate a horizontal force that depends on the marble depth. You might be surprised that this wall can hold back 11 centimeters of marbles before it overturns. Can you explain why the wall can resist a greater height of marbles when the bottom leg points towards them? Is there an additional force that comes into play? Recall that granular materials generate both horizontal and vertical pressures. When the bottom leg is oriented away from the marbles, overturning is resisted only by the weight of the wall itself, and so it overturns easily. When the bottom leg points towards the marbles, the vertical pressure from the marbles helps to keep the wall upright. The downward pressure also increases the friction between the bottom of the wall and the ground, thereby reducing the likelihood of sliding. When engineers design L-shaped retaining walls, they imagine them overturning about the point labeled Q. They first calculate how strongly the soil pressure will tend to make the wall rotate about Q. We call this tendency to tip an overturning moment, and we label it MO. Next, they figure out the stabilizing moment, MS, produced by the soil pushing downwards on the horizontal leg of the wall. Lastly, they make sure that the horizontal leg is long enough that the stabilizing moment is at least as large as the overturning moment. Then the retaining wall will be stable. You might be surprised to learn that L-shaped walls are seldom used as dams. The reason is that pressurized water at the bottom of the dam can seep under the base of the dam. And if it does, the resulting upward water pressure on the bottom of the dam can generate an additional moment and make the dam overturn. Lots of other clever approaches can be used to design retaining walls, but we do not have time to discuss them here.
So in that video, they discussed about L-shaped retaining wall. Okay, so discussed about L-shaped retaining wall and the reversed L-shaped retaining wall. So reversed compared to reverse L-shaped retaining wall, normal L-shaped retaining wall only has more stability. Okay, that only they discussed. The next type is counterfold wall. So next one is the counterfort wall. Okay, so I already mentioned what is counterfort wall. So counterfort wall as an extra uh, component, that is counterfort. Okay, so in this image you'll see, okay, this extra portion only we are naming it as counterfort. Okay, if we provide counterfort means we can increase the height of the stem. So that is the main advantage in counterfort retaining wall. Okay, so counterfort retaining wall is similar to cantilever retaining wall, but it has an extra component counterfort. Okay, so in counterfort retaining wall, stem and yield slab are strengthened by providing counterforts. Okay, the stem and yield slab are strengthened by providing counterforts at some suitable intervals. The stability of the wall is maintained essentially by the weight of the earth on yield slab plus the self weight of the structure. Okay, the stability will be more when compared to cantilever retaining wall. The stability of counterfort wall will be more. So this is an image of counterfort retaining wall. Okay, so these are counterforts. Okay, with suitable distances. This is one more image of counterfort. So this is the counterfort. Okay, in counterfort retaining wall also we are having toe slab and heel slab. Okay, so normally we'll provide counterfort in the back side only. Okay, where the landfill one is there only will provide counterfort. Okay, this is one more image. So for larger heights, okay, I already mentioned for large height, if we want to build a large height retaining wall means we'll go for counterfort only. Okay, so for larger heights in a cantilever retaining wall, the bending moments developed in the stem, heel slab, and toe slab become very large and require large thickness. The bending moments can be considerably reduced by introducing transverse supports called counterforts. Okay, so bending moments will be more. Okay, if we provide counterfort means the bending moments are reduced. So counterfort wall are placed at regular intervals of about one third to half of the wall height. Okay. So based on the stem height, okay, they are mentioning wall means that is stem height only. So based on the stem height, we can provide a counterfort distances, maybe about one third to half of the stem. Okay. So interconnecting the stem with the heel slab. Okay. So they are interconnecting, maybe concealed. Okay. The counterforts are concealed within the retained earth on the rear side of the wall, that is back side of the wall. Okay, this wall is economical for heights about 7 meters. Okay, so we can build the retaining wall up to a height of about 7 meters. So the counterfort subdivides the vertical stem into rectangular panels and support them on two sides, and themselves behave essentially as a vertical cantilever beams of T section and varying depths. Okay, so counterforts divide the vertical stem, okay, into rectangular panels, and they themselves behave as a cantilever beams of T section and varying depth. Okay, that only they are mentioning. Okay, so this portion, so this is the stem. Okay, if we provide counterfort here means the stem is divided. Okay, so it will also act as a cantilever. Okay, so counterfort act as a support, and this is a cantilever. It is also a cantilever portion. Okay, that only they are mentioning. Okay, so I'll stop here. Okay, up to counterfort retaining wall. So next class we'll see about anchored retaining wall and all. Okay, so this subject is about design only, not theory. But we have to know what is retaining wall, what are the types of retaining wall. So that only the first class I gave introduction about retaining wall and all. So next class you may have design. Okay.
சார் அனாலிட்டிக்கல் சப்ஜெக்ட் பண்ணீங்களா சார் இல்லை எப்படிங்க சார்?
ஆனால் டிசைன் தானே அனாலிட்டிக்கல் சப்ஜெக்ட் தான். டிசைன் பண்ணுவீங்க, நம்ம ஸ்ட்ரக்சர் அனாலிசிஸ் மாதிரி கிடையாது. டிசைன் ஆஃப் ஆர்சி படிச்சிருக்கீங்களா?
இல்லைங்க சார்.
டிஆர்சி படிக்கலையா? உங்களுக்கு நீங்க போன செமஸ்டர் படிச்சிருப்பீங்களே டிஆர்சி.
டிஆர்சி படிச்சிருக்கோம்.
டிசைன் ஆஃப் ரீஇன்ஃபோர்ஸ்டு கான்கிரீட் சார்.
அதான் அதே மாதிரிதான் அங்க என்ன பீம் ஸ்லாப் எல்லாம் டிசைன் பண்ணிருப்பீங்க. இங்க வந்து ரீடைனிங் வால் டிசைன் பண்றீங்க. ஓகேவா? ஸோ சேம் உனக்கு கான்கிரீட் என்ன ரேஷியோ, பாரோட சைஸ் என்ன மாதிரி டிசைன், ஸோ அதெல்லாம் தான் வரும். மேக்ஸிமம் ஃபுல்லா 5 யூனிட்ஸ்மே அதுதான். ஓகே, நான் ஃபர்ஸ்ட் கிளாஸ் அப்படிங்கிறனால இன்ட்ரோடக்ஷனுங்கிறதுனால அது பண்ணேன். ஒரு தியரி பார்ட் ஒரு பவர் பாயிண்ட் ஸ்லைடு போட்டு ஓகே,
சார் இதுக்கு கோடு புக்கெல்லாம் யூஸ் பண்ணணுங்களா சார்?
கோட் புக் எல்லாம் இருக்கு கண்ணா, கோட் புக்லாம் இருக்கு. ஆனா வந்துட்டு உனக்கு பாத்தீங்கன்னா உனக்கு இந்த சப்ஜெக்ட் வந்துட்டு ப்ராக்டிக்கலும் இருக்கு, தியரி எக்ஸாமும் இருக்கு, as well as ப்ராக்டிக்கல் எக்ஸாமும் இருக்கு. ஓகேவா? சிலபஸ்லயே
சூப்பர்.
கொடுத்துட்டாங்க எக்ஸாம் எப்படி கண்டக்ட் பண்ணணும்னு சொல்லி. உனக்கு தியரி எக்ஸாம் பாத்தீங்கன்னா
சரி
5 யூனிட்ல இருந்து ஒவ்வொரு கொஸ்டின் கேட்பாங்க, 20 மார்க் கொஸ்டின்ஸ். ஓகேவா? 2 மார்க். எக்கோ கேக்குது, ஆடியோ. சரியா? 5 பிக் கொஸ்டின்ஸ் வரும் ஒவ்வொரு யூனிட்ல இருந்து. ஸோ அதுக்கு 20 மார்க். ஓகே, ஸோ டிசைன் பண்ணி டிராயிங் போடுவேன். ஸோ தியரி எக்ஸாம்ல டிசைன் வந்துட்டு 12 மார்க், டிராயிங் வந்து ஃப்ரீ அண்ட் டிராயிங் தான் அந்த டைம்ல தியரி எக்ஸாம் அப்போ. ஸோ அதுக்கு 8 மார்க்ஸ். ஓகே, 100க்கு எழுதுவேன், அது 80க்கு கன்வெர்ட் பண்ணிடுவாங்க. ஸோ அதே மாதிரி ப்ராக்டிக்கல் எக்ஸாம் இது தனியாக ஒரு நாள் நடக்கும். ஸோ ப்ராக்டிக்கல் எக்ஸாம்ல 2 கொஸ்டின், பார்ட் ஏலேருந்து ஒன்று, பார்ட் பிலேருந்து ஒன்று, டிசைன் பண்ணி டிராயிங் போடுவேன், ஆட்டோ கேட்ல டிராயிங் போடுவேன். ஸோ இது 100க்கு எழுதுவேன், இதை வந்து 20 கன்வெர்ட் பண்ணிடுவாங்க. ஓகேவா? ஸோ டோட்டலாக 100 மார்க்ஸ். ப்ராக்டிக்கல் எக்ஸாம் வந்து நம்ம காலேஜில் இன்டர்னல் மோட்ல நடக்கும். தியரி எக்ஸாம் உனக்கு செமஸ்டர். ஓகேவா? வெளியிலேருந்து கொஸ்டின் ப்ரிப்பேர் பண்ணி வருவாங்க. 5 யூனிட்டுமே டிசைன் தான். ஃபர்ஸ்ட் யூனிட் ரீடைனிங் வால். ஸோ இந்த யூனிட்ல கேன்டிலிவர் ரீடைனிங் வால், கவுண்டர்ஃபோர் ரீடைனிங் வால் டிசைன் பண்ணுவேன். நெக்ஸ்ட் யூனிட் ஃபிளாட் ஸ்லாப் பிரிட்ஜ். ஓகே,
சரிங்க சார். ஓகேங்க சார். சார் இந்த செம்மு நடக்குங்களா சார்?
இந்த சம் வந்து மேக்ஸிமம் வந்துட்டு ஆன்லைன் கிளாஸ் தான். அதாவது உனக்கு ஜூலைல எக்ஸாம் பிளான் பண்ணியிருக்காங்க. ஜூலைல எக்ஸாம் வந்து முடிஞ்ச அடுத்த இது வந்து லீவ் எல்லாம் கிடையாது, காலேஜ் ஆரம்பிச்சிருவாங்க. காலேஜ் ஆரம்பிச்சாலும் பாத்தீங்கன்னா இந்த குவாரண்டைன் இருக்கும், நீங்க கிளாஸ்ல ரொம்ப இதா
சரி சார்.
சகஜமாலாம் இருக்க முடியாது. ஸோ மேபி அந்த ப்ரிகாஷன் மெஷர்ஸோட காலேஜுக்கு வருவீங்க.
சரிங்க சார்.
அப்புறம் வந்து பாத்தீங்கன்னா அதாவது ஓரளவுக்கு சுச்சுவேஷன் கண்ட்ரோல்டா இருக்கு, ஒன்றும் ப்ராப்ளம் இல்லை அப்படின்னா
சார் இப்போ
காலேஜுக்கு
ஆன்லைன்
வருவீங்க.
டெஸ்ட் எல்லாம் இருக்காதுங்களா சார்?
எல்லாமே இருக்கு கண்ணா, இருக்கு இருக்கு, அதான் சொல்ல முடியாது. இப்போ உங்களுக்கு ஜூலைல எக்ஸாம் பிளான் பண்ணிட்டாங்க. ஓகேவா? ஜூலைல எக்ஸாம் நடக்கும், நடந்து முடிஞ்சதுக்கு அப்புறம் காலேஜுக்கு
சரிங்க
வருவேன்.
சார்.
இப்போ உங்க கிளாஸ் நம்ம சிவில் பிரச்சனை இல்லை, ஏன்னா உங்க கிளாஸ் 35 தான். அடுத்த இன்னொரு கிளாஸ் 15 பேர் தான். ஸோ தனித்தனியா உட்காந்துக்கலாம். மற்ற கிளாஸ் 60 பேர்லாம் வந்துட்டு அப்போ அந்த டைம்ல எப்படி
சரிங்க
அலோவ்
சார்.
பண்ணுவாங்களா, பேரண்ட்ஸ் அலோவ் பண்ணுவாங்களான்னு தெரியாது.
ஆமாங்க சார். ஆமாங்க சார்.
ம்
சார் இது செமஸ்டர் வந்து ஆன்லைன்லயே இல்ல
சரிங்க சார்.
நம்ம காலேஜ் வந்து எழுத மாதிரி இருக்குமா சார்?